In this lesson, we are going to do examples of mole-to-mole stoichiometry. In the first one, number 11, this equation shows the formation of aluminum oxide, which is found on the surface of aluminum objects exposed to air. So the way we read this is 4 moles of aluminum plus 3 moles of oxygen. Gas yields or react to form 2 moles of aluminum oxide. So the first question asks, write 6 mole ratios that can be derived from this equation. Okay, and so the first mole ratio would be 4 moles of aluminum react with 3 moles of oxygen. The second one we can look at, 3 moles of oxygen react with 2 moles of aluminum oxide. And the third one would be 4 moles of aluminum react with 2 moles of aluminum oxide. And we could just invert all of those numbers to make 6. So we could take the 4 and 3 and flip that over and say 3 moles of oxygen on the top over 4 moles of aluminum. We can do that for all of those. Okay, the second part of the problem says how many moles of aluminum are needed to form 3.7 moles of aluminum oxide. So I'm going to write the given and unknown. So the given is 3.7 moles of aluminum oxide. And we're looking for how many moles of aluminum. So we always start with the given. In this case, 3.7 moles of aluminum oxide times, we're going to put moles of aluminum oxide on the bottom, and moles of the unknown, which is aluminum on the top. And we are going to use 4 moles on the top to 2 moles on the bottom. And our calculators, we'll do 3.7 times 4 equals, divided by 2 equals 7.4 moles of aluminum.
At 2:30 is car riders and drivers.
Number 12.
To the top at Victoria Road.
According to the equation, same equation, how many moles of oxygen are required to react with 14.8 moles of aluminum? So we will write down the given. This is A. Given is 14.8 moles of aluminum. Unknown is how many moles of oxygen.
We'll go ahead as scheduled.
14.8 moles of aluminum times, we're going to do the mole-to-mole ratio step between the given and unknown. So mole of aluminum on the bottom so that we can cross those out, and mole of the unknown on the top, which is oxygen. And so the oxygen will get a 3, and the aluminum will get a 4. So in our calculators, we will put 14.8 times 3 equals, divided by 4 equals 2. All right, and finally, B, it says how many moles of aluminum are formed when 0.78 moles of oxygen reacts with aluminum. So the given here is 0.78 moles of oxygen. The unknown is how many moles of aluminum. So we're going to start with the given, 0.78 moles of oxygen times mole of oxygen to mole of aluminum. And the moles of oxygen are going to be 3 on the bottom, and moles of aluminum are 4 on the top. And 0.78 times 4 equals, divided by 3 equals 1.04 moles of aluminum. Okay, remember the moles of oxygen to cancel out.